Hello everyone, welcome back to Math with Amala. Let's continue the chapter part 3. So we are continuing the properties. So the next property is commutativity. So we have discussed the closure property in the previous video. Please go through that video. Link is in description. So let's move to the commutative property. Formula for the commutative property of addition is a plus b equal to b plus a. So in case of whole numbers, 1 plus 2 equal to 2 plus 1, it is commutative. But in case of subtraction, in the whole numbers, 1 minus 2 is not equal to 2 minus 1. So it is not commutative. In case of multiplication, 1 into 2 equal to 2 into 1, it is commutative because both sides LHS and RHS are equal. So it is commutative. And in case of division, it is not commutative. Why? 1 by 2 is not equal to 2 by 1. Hence, the whole numbers are commutative only under addition and multiplication. Now, let's check the case of integers. For addition, minus 2 plus 2 is equal to 2 plus minus 1. It is right. So, we can say integers are commutative under addition. Next, minus 2 minus 3, which is equal to 3 minus minus 2. Are they equal? Let's check. Minus 2 minus 3 is minus 5, and also 3 minus minus 2 is plus 5. So they are not equal means it is not commutative. Integers are not commutative under subtraction. Now let's check the multiplication. Minus 1 into 2 is equal to 2 into minus 1. Both sides are minus 2. So it is commutative. Like the whole number itself, addition and multiplication are commutative here. Let's check the case of division also. Minus 1 by 2 is not equal to 2 by minus 1. So we can say it is not commutative. So the only commutative operations are addition and multiplication. So the integers are commutative under addition and multiplication. Now let us check the case for rational numbers. Let's check which all the operations are commutative in the case of rationals. So we are representing rationals as Q. In the case of addition, let us take two numbers 1 by 2 plus 3 by 4, which is equal to, let's cross multiply them, that is 1 into 4, 4 plus 3 into 2, 6 divided by 2 into 4. Here the answer we get is 10 by 8. So if we take the 3 by 4 plus 1 by 2, there also you will get 10 by 8. Now let's move to the next, which is subtraction. In case of subtraction, so we can say here, in the case of addition, addition is commutative for rationals. Or you can say rationals are commutative under addition. Okay. Now let's take the case of subtraction. Let's take two rational numbers 3 by 5 minus 5 by 2. Let us make this 5 by 2 to a simpler one. Let's take 1 by 2. 1 by 2. Okay, 3 by 5 minus 1 by 2. That is 6 minus 5 by 10. That is 1 by 10. Again 1 by 2 minus 3 by 5 is equal to 5 minus 6 by 10, which is equal to minus 1 by 10. So it is clearly visible that both are not equal. Hence we can say that subtraction is not commutative for rationals. Okay, so in other words, we can say rationals are not commutative under subtraction. Now let us check for multiplication in case of rationals. In multiplication, let's take two numbers, rational numbers minus 7 by 3 into 6 by 5. Let's multiply it through the straight multiplication. Minus 7 into 6 by 3 into 5 minus 42 by 15. Then its reverse is minus 42 by 15. So it is commutative. We can say multiplication is commutative for rationals, or in other words, rationals are commutative under multiplication. Okay. Then the remaining is division. Let's take minus 7 by 3 divided by 1 by 2. In case of division, we have to take the reciprocal of the second number and multiply it with the first. So minus 7 by 3 into reciprocal of 1 by 2 is 2 by 1. So the answer is minus 14 by 3. Let's take the reverse, 1 by 2 divided by minus 7 by 3. Again you will get 1 by 2 into 3 by minus 7. So that is 3 by minus 14. It is visibly clear that these two numbers are not equal. So we can say division is not commutative for Q. In other words, rationals are not commutative under the operation division. So Q is not commutative under division. So this is all about the closure property, commutative property. Now we have to discuss associativity. Thank you all for watching the video. Please stay tuned for the next video to continue with associativity.